Um, if the extra revenue, the marginal revenue, is greater than the marginal cost, then that means if I increase my output, my revenue is growing faster than my costs are growing. So what would happen? Well, my profits would go up. If the marginal revenue is less than marginal cost, that means as I increase quantity, my revenue is growing slower than my costs. My costs are growing at a faster rate than my revenue is growing, which means my profits are going down as quantity goes up. It also means my profits are going up as quantity goes down. I should make less, in which case my marginal revenue would be going down, but my marginal cost would be going down faster. So decreasing your quantity would make your profits go up if this is true. So the only way I could be somewhere where any change makes my profit go down is when my profits are at their maximum, which has to be here, where marginal revenue and marginal costs are the same. So if I could find the quantity where these two are equal, then I'm ready to set the best possible price for the beer on an airplane. You can also do this with calculus. It's pretty straightforward if you know calculus. If you don't know calculus, then of course it's a horrible pain. But if your brain enjoys it, if not, just skip ahead about a minute. Profit equals total revenue minus total cost. Where is profit maximized? Where the change in profit with respect to quantity is equal to 0. The change in total revenue with respect to quantity, change in total cost with respect to quantity equals 0. Well, what is this? What is the change with revenue with respect to quantity? That's just marginal revenue. And what is the rate at which my costs are increasing as my quantity goes up, as my production increases? That's just the marginal cost. So profits are at their maximum where marginal revenue minus marginal cost equals 0. In other words, when these two are equal, which is the same result that we just showed. You'll see this in your book. Yeah, I'll do it. If quantity is given as the quantity demanded is something like 80 minus 5 times the price, and I know that the marginal cost is equal to 2. For instance, as just an example, you can ask what price maximizes, or what quantity and price maximize my profits. The trick is if you rearrange this and solve it for price, this is called a demand curve. This is called an inverse demand curve. It's the exact same thing. Mathematically, it's just rearranging it in terms of price. The marginal revenue is equal to 16 minus, if this is 1/5, here's the trick, 2/5. And then I set that equal to marginal cost, and you can then just solve it for Q. I trust you can do it. How did I get this trick from price equals to marginal revenue? It's actually pretty easy, but you have to do one little thing. Let me do it in generic terms first. E minus BQ. Then marginal revenue, total revenue is price times quantity, which is AQ minus BQ squared. Marginal revenue is just the first derivative of this, which is A minus 2BQ. So if I start off with a linear demand curve, price equals 80 minus 5q. Sorry, 16 minus 1/5 q. Marginal revenue, you've got the same constant, but you just double the slope. So this is derived in the a footnote in your economics textbook, but here it is again, just so you can kind of see where this rule is coming from. It's a real quick trick. You go from whatever the slope is in the inverse demand curve, and you just double it, and you calculate marginal revenue. And from there, setting this equal to marginal cost gives you a very quick equation with which you can solve for the quantity that maximizes profits, and then you can plug that in here to solve for the price that you might charge so that people will buy that quantity. And now you have made as much money as you can.